today we have two boilers that are hot water boilers. They're both the exact same size. They feed a commercial building, and again we have redundancy here. So one boiler is more than efficient to heat this building, but we have two just in case we have to shut a boiler down, or if it's very cold in the morning, or you get a sudden drop in temp during the day and you're trying to heat the building up as quick as you can. This boiler will get a full call for heat, and if it can't keep up to get up to temp, then this boiler will help it. Or you can also stagger the boilers, where you might have this be your primary for 1 week, and then that boiler becomes your primary for the other week. So you're actually prolonging the life of your boilers. As in steam boilers, we have a control. So when this fires up, if this was turned on, which right now it's off, in the off position, you would have your power button would show, and if we got a call for heat, it would show the light for pilot, the flame, and then the main. And as discussed with steam, if we went into alarm, then we would have an issue and this would shut down. So if it goes through that whole process and we light up, on the bottom here is where we have our burner tubes. And our flame comes up, and we have tubes in here with water. And what we're doing is we're heating up the water. Now, if it was a steam boiler, we're trying to get up to 212 degrees to make steam. Here, we're not trying to do that. We're trying to get to about 180 degrees, 185 degrees for our feed. And if our system is running correct, when it runs out through the building and goes through all the various different coils, with our heat loss, we should get our return being about 160 degree water. You should see about a 20-25 degree drop. You may have it where you have an output of 180 and you get a return of 140. If you're getting a 40 degree drop, you're still going to heat the building, but that means that you're putting out 180 degree water, and by the time it circulates through the building, you've lost 40 degrees. So now you have to take that water back here and heat it back up in order to get that 180 degree. That also means that you could have potential areas in the building, if you're getting a 40 degree drop, that you're not heating efficiently, but we'll talk about that in other videos. So what you have here is you have your supply right here, and you have your return right here. Okay, so water gets heated, goes up out that way, water comes back here. Here we have for our flue gas. So just like in steam, we're making combustion. This is a gas boiler, natural gas, which means we have a flame, we produce carbon monoxide, and we have to be able to vent it. This is vented into the chimney, which goes up to the roof and vents safely. Now, as in our hot water supply and hot water return, in steam we had a supply and return, but that was propelled by the steam pushing. Okay, here the water will not move unless it has pump pushing. So this pump has the heating water supply and the heating water return. So the water comes in, the water moves out, and it pumps throughout the building. And we also get into air handlers and what it's doing in there, which we'll do in another video. But what you have here is we also go to the expansion tank. And this is a part that a lot of people seem to forget. In the expansion tank, when water heats up, it expands. And you have to have a place for the excess water to go. If the expansion tank is filled, then what's going to happen is your relief valve is going to go off because you have an issue with your expansion tank.